Hi everyone. So today we're going to figure out how we can solve for a missing side length of a triangle that's not necessarily a right triangle. So imagine that two firefighters are located at points A and B, 4.2 miles away from each other. Now, suppose there's a fire at point C and we want to know how far firefighter A is from the fire. Now, before we proceed further, it probably makes sense to figure out the angle at C. Now, we can do this keeping in mind that the interior angles of a triangle have to add up to 180 degrees. So if we add 36 and 28, we get 64. And then when we subtract 64 from 180, we get this angle right here, which is 116 degrees. So on your notes packet or in your notebook, you could just label that this angle right here is 116 degrees because that's going to make things easier going forward. Now, how do we actually solve for the distance between the firefighter, which is firefighter A, and the fire at C? Well, we can't use SOHCAHTOA in this case just because we're not dealing with a right triangle. However, we can use a new rule called the law of sines. The law of sines can be used in a couple different cases. So the first case is the case in which we're given two angles and a side of the triangle, and that's exactly what we have here. So we've been given two angle measures, which are the 36-degree angle and the 28-degree angle, and a side length. So we're also given the 4.2 miles as a side length. The second case in which we can use the law of sines is the case in which we're given two side lengths and a non-included angle of the triangle. So what that means is two side lengths and an angle located opposite one of those two sides. So the law of sines tells us that the sine of an angle A over the side opposite of that angle, which is little a, equals the sine of an angle B over the side opposite that angle, little b, which equals the sine of an angle C over the side across from that angle, little c. So just to clarify, big A, big B, and big C refer to the angle measures of the triangle. Little a, little b, and little c refer to the sides opposite those angles. So for instance, little a is the side opposite of angle A. So you'll notice that on this page, I've labeled the triangle according to which side is across from which angle. So side little a is across from angle A, side little b is across from angle B, and side little c is across from angle C. So now that we've properly labeled our triangle, we can fill in the law of sines formula with the information that we've been given. So we have the sine of 36 over the side opposite 36-degree angle, which is A, equals the sine of 28 over the side opposite the 28-degree angle, which is B, equals the sine of 116 over the side opposite the 116-degree angle, which is little c, or 4.2 in this case. So our next order of business is to set two out of our three ratios equal to each other to solve for B, which is the side we want to solve for, the distance between the firefighter A and the fire. So obviously we do have to use the ratio that contains B, which is sine of 28 over B. And we want to set it equal to the ratio for which we have both the angle and the side across from it given. So that's not this ratio, obviously, because the sine, we have the 36-degree angle, but we don't have the side length across from that 36-degree angle. So we can scratch this and not even have to deal with it. So we're going to set the sine of 28 over B equal to the sine of 116 over 4.2. And now we're going to go over how do we actually solve for the value of B. So now we're going to do some cross multiplication in order to figure out the value of the variable that we're looking for, which is B. So when we multiply B times the sine of 116, we get B sine 116. And then when we multiply 4.2 times the sine of 28, we get 4.2 times the sine of 28. So we're just going to set those two quantities equal to each other. Now, in order to solve for the variable B, we're going to divide both sides by the constant that's being multiplied by B, which is sine of 116. So you'll notice that down here, we divide both sides by the sine of 116. And we can actually just type this part into our calculator the way we see it, assuming it's in degree mode already. If not, you want to put your calculator in degree mode. On a TI-84 Plus graphing calculator, you can do that by hitting the mode button and making sure your calculator is set to degree instead of radian. So when we divide both sides of the equation by sine of 116, the sine of 116 is going to cancel over here. And notice here, when we do 4.2 times the sine of 28 divided by the sine of 116, we're going to get back 2.2, which shows us that the distance between firefighter A and the fire at angle C is going to be 2.2 miles.